Hi guys, welcome to this video on the final triangle congruence shortcut, angle, angle, side. Angle, angle, side, the prerequisite for this is knowing that angle, angle, side does not use any included sides or angles. So if we look at the diagram below, okay, remember then that included side angle refers to a side or angle that is sandwiched or located between two consecutive angles or sides. So in angle, angle, side, angle B and angle A, their non-included side would be side C. So just keep that in mind as we do our definition of angle, angle, side. Angle, angle, side says that if two angles and a non-included side in one triangle are congruent to two corresponding angles and a non-included side in another triangle, then the triangles are congruent. So because angle A is congruent to angle Y, and angle B is congruent to angle Z, and a non-included side AC is congruent to XY, I can now say that triangle ABC is congruent to triangle XYZ. So let's do an example proof here. All right, prove that PKQ is congruent to NKM. So like all of my proofs, I'm going to start by writing out what it is I am trying to prove. So PKQ congruent to triangle NKM. That is what I am after. So let's see what we can do here. What's given to me immediately is that angle P and angle N are congruent. So I'm going to start with that. So angle P is congruent to angle N. That is given. Okay. The next thing I can say is that side MK is congruent to side QK. So we'll say side MK is congruent to side QK. Oop. My K went a little haywire there. And that is again is given information. And now I don't have any other markings on this diagram, so I'm going to have to make an inference myself. So these diagrams looks like two triangles that are stacked on top of each other. So I do see though that these angles here are vertical angles, so I can conclude they are congruent by the vertical angles theorem. So angle MKN, so angle MKN is congruent to angle, not triangle, PKQ because of the vertical angle theorem. And now I can say that the two triangles are congruent, and I can say that because of angle, this angle here, angle, and an unincluded side. So I can say it through angle, angle, side, since the side is not in between the two angles. And that's it. That's how you use the angle, angle, side congruence shortcut. Thanks for watching these videos on the congruence shortcuts. I'll see you in the next video for CPC TC.